Hi everyone, it's Mrs. Bebo. In this video, we're going to continue talking about graphs of proportional relationships. And to recap what we did last time with just quickly identifying if a graph shows a proportional relationship or not, we're actually going to practice plotting some points and then determining whether or not it's a proportional relationship. So in this example that we see here, we have the cost of a 3D movie ticket. It's $12 for one ticket, $24 for two tickets, and then $36 for three tickets. We're going to determine whether the cost is proportional to the number of tickets by graphing the relationship on the coordinate plane. So we're going to go ahead and have number of tickets on our x-axis, and the cost is going to be the y-axis. So we can go ahead and label that too. So this is our tickets here on the x-axis, and then over on the y, that is going to be our cost. So when we take a look at this first one here, so it's one ticket for $12, that's going to give us the ordered pair 112. Two tickets for 24, so 224. And then we have 336. So we're going to go ahead and again plot all of those on our coordinate plane that we have here. So 224 and then 336. If we were to draw a straight line through this, which I'll do the best I can, we would find that this ends up being a straight line that goes through the origin, and so we would say this relationship shown is proportional because the graph is a straight line and it goes through the origin. So those are the criteria that need to be met in order for a graph to show that it's proportional. All right, so we're going to take a look at one more like that, where we can again practice getting our ordered pairs and then plotting the relationship in this coordinate plane. So the table shows the number of calories an athlete burns per minute of exercise. We're going to graph the relationship and again determine is it proportional or not. So we have the point 0, 0, which is a good sign because it does need to go through the origin. Then we have this point 1, 4. Then we have the 0.28, again, just listing my x value and then my y value. So typically with tables, unless it says otherwise, it's going to be x on the left-hand side and y on the right-hand side. And then our last order pair would be 5, 10. So we can quickly plot those out. We got 0, 0. Then we have 1, 4. We have 2, 8. And then we have 5. And then we have 10. So if I were to connect these, it starts off good, but that 5, 10 is really throwing this off. It is not following the same ratio as the other pairs that we have in this table. So we would conclude that this relationship shown, we're going to say it's not proportional or non-proportional because the graph is not a straight line. And it does pass through the origin though. So, I mean, that part's good. Or we can say goes through, but passes through. But the whole idea is, again, that it cannot be curved and it has to go through the origin. So it's got to be a straight line going through the origin, which this does not meet. So that's a recap of what we talked about last time, just a little bit more involved where we actually have to get the points and then plot them. So what we're going to really focus on is, again, identifying that constant of proportionality. What's really nice about this is that it's not too involved mathematically. We just have to remember this piece right here. The constant of proportionality is the ratio of y to x for any point on the line except 0, 0. Because 0 divided by 0 would be undefined, right? So we would not have that be one of the points we would check. So if we know, for example, in this graph that we see here on the screen, this is a proportional relationship because the line goes through the origin and it's a straight line. For any of these three orange dots that I've highlighted, we can find the constant of proportionality, and it doesn't matter which one you pick. So if I were to start with the point that's here at the bottom, this is the point 210. If I'm going to find k is equal to, again, your y divided by x, so 10 divided by 2, which is equal to 5. If I were going to test it for this middle point that I have highlighted here, this is the point 315, And again, our k value is equal to y over x. It's the ratio of the y value to the x value. So we would write 15 over 3, which simplifies down to 5. And then, last but not least, we can test it for this last one, which is the ordered pair 420. So we have 420, and again, k is equal to the ratio of our y, in this case 20, to the x, which is 4, and that simplifies down to 5. So what this tells us, again, it didn't matter which point I picked. This is just to prove that every single one turns out to be exactly the same. You only have to test it once. So again, if you determine it is a proportional relationship based on the fact that it's a straight line that goes through the origin, you just have to pick one ordered pair to calculate the value of k. In this case, we proved it 3 times that k is equal to 5. All right, so take a look at this next example. In this one, the black mamba is the fastest snake in the world. Assuming the snake travels at a constant rate, the distance it travels is proportional to the time spent traveling. So it tells us already it's proportional. We're just going to practice again finding that constant of proportionality. So we have our time on the x-axis, and then we have our distance on the y-axis. Again, we're going to ignore this point here. We're not going to find k based on that value because, again, it's 0, 0, and we cannot use that. But we do know there is a constant of proportionality because, again, it tells us in the problem it's a proportional relationship. But also looking at this graph, it does go through 0, 0, and it's a straight line. So you can pick any of these points. I like to pick ones that I can clearly see what the values are. So I'm actually going to pick this one at the very top because I can see that this is the point 4 and then 60. Another point that would be good to pick could be this one here. So that would be the point 230, and hopefully as we're looking at that, you can kind of see that those are going to end up being the same when we do our k value. So again, I'm just going to focus on this top one, the 460. So I'm going to erase that one so it's not in our way. So again, k is equal to the ratio of y over x. So k is going to equal my y value, in this case, is 60, and then my x value was 4. So 60 divided by 4 is going to give us a k value of 15. So that is my constant of proportionality. That is all we had to do to figure out that piece of it. Describing it, what it means is essentially just putting labels with it, right? So in this situation, we're looking at seconds and feet. Now remember, you did our y to our x value. So we're doing feet per second. So if I put those labels with what this 15 is referencing to, this is saying that this black mamba moves 15 feet per second, which is crazy. So that's what it says when it describes, when it says describe what it means, just add some labels to it. What is it talking about in this situation? It's talking about how fast this black mamba can move, which is 15 feet per second. All right, so we're going to take a look more, especially at the analyzing piece and interpreting what a value means. And we're going to take a look at, again, the constant of proportionality and then interpreting what the point 0, 0 even means. So taking a look at this image that we see here, the graph of every proportional relationship, again, passes through the origin and is a straight line. The point 1, comma, r, where r is just some value, that actually tells you the constant of proportionality or the unit rate. So if you have that point on your graph and you can identify where x is 1 and then whatever that y value is, that actually is your constant of proportionality. You wouldn't have to do any extra math to figure that out. So we're going to take a look at this example here. We're going to analyze a few points on this. So in a recipe for trail mix, the number of cups of sesame seeds is proportional to the number of cups of dried fruit as shown in the graph. So we have cups of dried fruit on the x-axis, cups of sesame seed on the y-axis. What do the points 0, 0 and 1, 1.5 represent? So in the mix, when there are 0 cups of dried fruit, so again, we're looking at this point down here. If there are 0 cups of dried fruit, there are 0 cups of sesame seed. It really is that simple. Don't overthink this. Just means you have nothing. 0, 0. No cups of dried fruit and no cups of sesame seeds. Now for this next piece, the 1 and 1.5, keep in mind again what each variable is talking about. So the 1 again is our x-axis, right? So we're looking at this point here now. And again, we're looking at 1, so that's our cups of dried fruit. So then that means there are 1 cup of dried fruit for every, and again, this was at the 1.5, so for every 1.5 cups of sesame seeds as the mix is made. That's it. So basically when we're interpreting this or we're analyzing these points, we're essentially just adding labels. And again, if we were to say what K was, this point right here that I have circled in blue, that is my K value. So our K value would be that ratio 1.5 to 1, which is just the same as 1.5. Some of us might say, we could say it's 3 halves. If you don't want to have it as a decimal, those would essentially be the same thing. So that's that. All right, let's take a look at example 5. So we're going to select all the statements that apply to what we're seeing in this graph. So a lot of times in math, especially if you're working on an online program, they have questions like this where it's a multi-select, right? There could be one that's true, all of them could be true, but we're going to find out. So the cost of a smoothie is proportional to the number of ounces in the smoothie as shown in the graph. So the cost is proportional to the number of ounces. So we have ounces on the x-axis, cost on the y-axis, and we're going to select again all the statements that apply. So A says that the unit rate is 0. Well, that doesn't really make sense, right? The unit rate's not going to be 0 because again, it has to be per 1, and we can hopefully see that we do have a value here where x is 1, and then we have our y value. So the unit rate is not going to be 0. So this one is not going to be true. So I'll use red to cross that one out. That one's not true. The unit rate is a half. Or the unit rate is 1. So we actually have two options here. We got B and C that are still both talking about unit rate. So that point that I highlighted in blue, we're going to take a closer look at this. And again, we could even use this value here to help us find K. Both of them are going to give us the same result because this is a proportional relationship as it states in the problem. Plus, again, our knowledge of knowing that it goes through the origin and it's a straight line means it's proportional. So if I take a look at my K value, which remember is the ratio of y to x, right? This is going to get me my unit rate. Well, this point actually just tells me my unit rate right off the bat. So it's a half, right? Or 5/10. If I were to check it with this top point here, 4, 2, same idea. We would have y to x, so 2 to 4, which simplifies to 1/2, which again remembers the same as 0.5. So that is true. So the unit rate is going to be 5/10 or 0.5 or 1/2, however you want to word that. So this one is good to go. The unit rate then is not 1 because there's not going to be multiple unit rates. It's the one that we just figured out, a half, right? So this one is not true. All right, so for each smoothie, it costs $1.50 for every 1 ounce, or it costs $2 for every 1 ounce. And then we have some other options too here where we're trying to figure out if those are true or not. So if I take a look at our ratio here, and I'm actually going to go back and take a look at when we had it written as a fraction, this 1/2. So remember our y value is talking about the cost. So if we added some labels, you'd have $1 over, and then this would be considered 2 ounces because again, our x value is talking about ounces. So all I did was take this half and then add some labels to it. So now that we see that, we should be able to find a statement that matches what I have written in yellow there. So it's not the $1.50 for every ounce. So that's not going to be true. And it's not going to be the $2 for every ounce either. It actually ends up being, for each smoothie, it costs $1 for every 2 ounces because when I added those labels on there, again, y being dollars and then our x value being ounces, it showed me, again, that it's $1 for every 2 ounces. So that is helping prove this statement here. And then $2 for every 4 ounces, well, that's just double of what we just looked at. And that is also going to be true. And it actually goes back to this here, right? That unsimplified ratio of 2 to 4 is proving that piece right there, that it's $2 for every 4 ounces.